I'm Amanda, and this is my Inquiry 4. For Inquiry 4, I did not take a problem and turn it into a 5E lesson. I actually developed a tool, the Pocket Sundial, and then used it to make a 5E lesson. This Pocket Sundial measures the altitude of the sun. It's printed on cardstock and can easily be assembled or folded down into the size to fit into your pocket. So, it stands with a paper clip, very simple, very cost efficient for teachers. My issue when I was trying to do Inquiry 4 was deciding exactly what context I was going to use the sundial in. There are many options. It has history to it with the history of sundials. It has a lot of geometry to it, using angles and such with the earth. It also has a lot of math in it. There's proportions and altitudes. There's also science. There's discovery, hypotheses, science experimentation. The method that I went for this inquiry, I developed a 5E lesson that is a math lesson. Its objectives is to teach proportions, understand circumference, and to, in general, find the circumference of the earth, because that's cool. So, what I did for the engagement is, as students come into the room, they are told to find their groups. I've already assigned them groups. They will then sit down and see that they have a styrofoam ball, a 2-inch measuring tape, and a protractor. They are instructed that they must find 2 ways using these tools to find the circumference of the styrofoam ball. This will really help me to get the same ideas across before we go into finding the circumference of the earth. That is the point of this exploration activity. The students will explore. They are told to find a practical method and a mathematical method. Practical method, most students will take the 2-inch measuring tape and just circle around the ball, counting it up. Mathematical method is the one that students will struggle with a little bit more. Hopefully, some students with some scaffolding will come up with the idea that they could set up a proportion. What I mean by proportion is if you have a circle and you can measure this area, then you know this outside distance. They could then, this could be their 2 inches, then they could measure this angle using the protractor. They could then set up a proportion. This information will be assimilated to the earth. This is X number of miles on the earth, and this angle is actually the latitude, or the difference in latitude between the 2 points that the distance is measured. The proportion would then be set up as follows. You would have the X number of miles, or in the case of the styrofoam ball, the 2 inches, divided by the angle. Now this could be the latitude of the difference in latitude when doing the earth, or the angle measured by the protractor when doing the styrofoam ball. You set this equal to the entire circumference over the entire angle of the circle, which is 360 degrees. Students would then solve for circumference. Using that information to solve the circumference for the styrofoam ball, the teacher in the explanation will walk them through this procedure exactly. Although all the other ideas will be shared from other students, this is the one that will be focused on because it will be used in the elaboration. An example problem is also provided for that. In the elaboration, students are asked how they could find the circumference of the earth. They just found the circumference of a small styrofoam ball, but how would they find it of a much larger planet? Students are encouraged to think about it, throw out ideas. Many will think of spaceships or driving around the earth. Although these are impractical, you want to ask students how they, without fancy tools and without being able to drive around the earth, could measure it. And the answer some students will come up with is that maybe they could use this proportion. Then the answer is, how do we measure the angle of the earth? This gets into a brief discussion about latitude and the sundial. The sundial will measure altitude, which can then be put into an equation, which will calculate latitude. They can calculate their own latitude, look up the actual, and see how close they are. Usually students will be within 1 to 2 degrees. From there, the students on the next day, they will be given this as homework and told to put it together. On the next day, they will come in, you check the sundial, And then you take them outside to measure the sun. They measure the altitude and you record measurements all during the day. This is a 3-day lesson because of all the data that has to be collected. On the third day, when the students come back, they can use the data that was measured the day before, and they can graph it, find local noon, and then use that to find their latitude. From there, you need another latitude. Because the difference is a difference in latitude, you need to know between 2 points what is their distance and what is the angle between those 2 points. You can do it from the equator and just have the equator as 0. However, this also lends itself to be very useful that you could, for instance, Skype a family member who is in another area of the country, or even a partner school where you both could teach the lesson and the kids could do it together. But you need to make sure that you do a north to south distance. The circumference of the Earth, when we go around, is not a squiggly line, so it needs to be a north to south distance. If it's not exactly north to south, just use simple Pythagorean theorem to figure out the north to south distance. So students will have the X number of miles between the 2 points, and they will also know the difference in their latitude. That is their angle. They plug this into the proportion and find the circumference of the Earth. This usually happens within 3 days. You can spread it out if you want depending on the weather, because this is dependent on sunny weather. Another interesting point to make is that the circumference of the Earth may be off based on their calculations. If the students measure 1 degree off using the pocket sundial, then their end calculation could be off by 1,000 plus miles. So this is something to take into consideration. The rubrics that are suggested for this activity are based on the numbers that the students used and how well they did the calculations, not on their accuracy, which I recommend. Other than that, that pretty much sums up this inquiry. If you have any questions or you would love to do it with your students, you can contact me. You can also find the teacher's guide, student materials, and entire lesson plan online. Thank you.